All right, so now I want to take just a little bit deeper dives into some of the specific shapes. So there's the powers greater than 1 set first, and I'm looking at a few of these. I have an x squared, an x to the 4th, an x cubed, and an x to the 5th turned on. So x to the 2, 3, 4, and 5. And I want you to see, first let me zoom back out a little bit, that if we're looking out here as x gets really, really big, your y is getting really, really big as well. And the bigger the power, the faster it grows. So this is your x squared down here, growing quickly, but x cubed is definitely faster than that, x to the 4th even faster, x to the 5th. So as x gets big, bigger powers grow more quickly. But there's this weird little quirk with these graphs. The opposite is true between 0 and 1. So notice they all meet at 1, 1, and that's even true of our powers between 0 and 1 and our negative powers. All of them hit 1, 1. So between 0 and 1, notice that the x squared graph is actually giving us the biggest y value, followed by x cubed, x to the 4th, and x to the 5th. So between 0 and 1, you're taking very small numbers and raising them to bigger powers makes them even smaller. So basically, between 0 and 1, we'll keep focusing here because we have even and odds. The bigger your power is, the more it kind of squares out, flattens out near the origin and squares out here between 0 and 1. So that's kind of an interesting thing to notice. And that's true whether your powers are even or odd or whatever. I mentioned that because I'm about to look at the differences between even and odd. So let's go ahead and do that. I'm going to turn off all the odd powers and turn on a couple more even powers, sort of similar effect between 0 and 1, similar effect out here as x gets big. And then I want to look at both sides. And one thing I would like you to notice, again, x squared is your parent function, so add that to your chart if you haven't already. They're all even functions. So all of our even powers greater than 1 give us even functions, even symmetry, symmetric across the y-axis. And they're all kind of reminiscent of that parabola shape, right? They're not parabolas. They get flatter near the origin and steeper after we pass through 1, 1 and negative 1, 1. So there's definitely some skew happening there as the powers get bigger, but they all have a similar shape. So even power functions have a definite kind of trend happening here. Okay, let's look at the odds now. So there's x cubed, 5th, 7th, and 9th. Okay, and I'll show you quadrant 3 as well. So I'm hoping right away it jumps out at you that we don't have the mirror image anymore. We have something going on in quadrant 1 and then something going on in quadrant 3. This is rotational symmetry. This is odd symmetry. So you can visualize it either as flipping across the y-axis and then the x-axis, or picking the whole graph and rotating it 180 degrees. And either way, you get back exactly what was already there. So these functions, the odd power functions, are all showing us odd symmetry. They all cross through the 1, 1 as well. They all cross through the 0, 0. This time, though, we cross through negative 1, negative 1, because odd powers aren't going to eliminate those negative signs the way even powers did. Otherwise, very similar. As x gets really big, so does y. The bigger the power, the more extreme that is. Between negative 1 and 1, it actually flip-flops, and the smaller powers actually give you the biggest y value. And then this time we have an opposite thing happening. As x becomes a large negative number, y also becomes a large negative number, instead of the even powers, where y becomes a large positive number regardless. So you will be asked to analyze some statements like these bottom two as x goes to infinity. So we'll answer them for the power functions here. So what we're seeing as x goes to infinity, that's how you read that. This is like baby calculus notations, just the beginning. We would say the y also goes to infinity. And you'll be doing this in my open math, so you won't have to type that out or anything, but just for you to know what we're looking at here. And then for the odd power functions, we have something a little different. As x goes to negative infinity, y goes to negative infinity as well, whereas the power functions both would have been positive infinity. So you will have to look a bit at that global behavior as you zoom way out. What do you see your y's doing? Okay, so I think that's a pretty good look into these powers greater than 1.